Hey, let me run you through Google's Lightweight MMM library. So we're using Google Colab, which is like a Jupyter notebook. If you haven't used that before, makes it simpler because Google gives us a free environment to run this code. We don't have to worry about local setup on our computer, which is quite often the thing that stops beginners from learning how to code. So you won't really need to know how to code necessarily to run this. If you just follow along and kind of run the cells as you go, you can do that, and it will run. But obviously, if you understand a little bit of code and you can make a few changes, then you should be able to modify it for your own needs. So the library we're using here is Lightweight Bayesian Marketing Mix Modeling. It's not an official Google product, but it is a handful of Google engineers that are working on it. And a few things that are really exciting are one is that it's Bayesian. Facebook Robin is a kind of competitor in this space, and that's using ridge regression and an evolutionary algorithm. So very, very different approach, Bayesian, and there's a few advantages. The other thing that's cool about it is it's in Python, and I write Python. Don't know that much about R. So whenever I'm using Facebook's tool, I'm a little bit in the dark. I have to kind of look up everything to figure out what each R command does. Cool. So obviously it comes down to your personal preference and then whatever results you get. So first thing you need to do is pip install LightweightMMM. The way you do that is just to put a percentage sign in front, and then it will run all this. It does take a little bit of time, so I'm not going to run this again. One thing I will say is it will get, like at least if you have the same error as me, you get this error at the end and you need to click restart runtime. Do that first because the actual algorithm takes some time to run as well, and you don't want to have to get all the way down there and then have to restart again. So when it's restarted, it will come up here, and then you're good to go. Okay, cool. So, presuming that's already run, the way actually you run a cell here is you can click play, or you can just press Shift and Enter or Command Enter if you're on a Mac, and then it will run the cell. You don't have to run them in order, but helps. You're going to run into issues if you don't run them in order, so it always helps to kind of keep them in a strict order. So what we did here is we just pulled in a few helper libraries that we need. We also set our Colab to use two cores. It makes it run faster. We also imported the different libraries that we need. So that will help us optimize the media. Then this will help us actually run the model. We can plot some of the charts, and then there's some utility and pre-processing libraries there as well. Cool. So first we have to simulate the data for modeling. I'm not using a real data set. I'm just simulating the data using their utils. You could obviously use the data if you get it into this format as well. You could use whatever data you want. But just for this exercise, we're just going to simulate it to make it easier. The data size here, it's 104 weeks, and then 13 weeks of test data. The one cool thing about this is it's very built specifically around train and test, and that means you can see the accuracy on data the model hasn't seen yet. So I highly recommend you use this and you do the train test split in a way that is more of like a time series way. So you want to chop off like the last 13 weeks of data rather than kind of using random weeks like you might have used in other data science projects, because that's what marketing mix modeling is doing. You're trying to predict the future, and you're not trying to predict random weeks the model hasn't seen in the past. You want to kind of say, okay, well, if I predict the next 13 weeks, how is this channel actually going to work for me? Like, is it actually going to predict the future? Like, am I confident in this? A few other things we're doing here is like, one, we're setting 3 media channels. We have one extra feature, which is basically, it could be any organic variables, anything you seem important, like maybe your, how much blog content you've put out, whatever it is that affects the sales, but isn't a media channel. Like, you're not spending ad dollars to promote in that channel. And then you want to simulate the data. So this is going to output media data, extra features, the target, which is sales in this case, or it could be conversions, and then also costs. So we're just going to get those out here. And just to see the shape of them, this is arranged into geos. So that's one cool thing about LightweightMMM straight out of the box, is that it lets you do geo-based or geo-level marketing mix modeling. In the past, I've found that this helps you drive much more accurate measures of how well marketing channels are working. Because if you think about it, if you just have 104 weeks worth of data, that's fine. That's 104 observations, but you typically need like 10 observations at least per variable, and a lot of those variables are quite like correlated. So if you spend a lot on TikTok at the same time as you spend on Google or Facebook, then it's going to be hard for the model to tell, was it Google that drove the sales or was it TikTok? So by adding in geo, you're adding in more variance and more observations. Now, if you have two geos, you have twice as many. So like if you have split the US into like East US and West US, that would give you twice as much variance. Some days you would have spent more in New York, other days you would have spent more in San Francisco. So it gives the model, some more data to really figure out the incrementality of each channel. Cool. And you can see that in the shape here. So there's 117 rows, the media data. So that is the 104 plus 13. And then there's 3 media channels and then 2 geos. So that's the shape there. Cool. So next thing is to get the train data ready. So the split point is the data size minus 13, because we're keeping off those 13 weeks. We're not giving them to the model when we're training. Then we create the media data train, media data test. So this is really just finding everything up to the split point for all geos, and then everything from the split point is the test for all geos. So that's how that works. So this colon is saying everything up to the split point, and then this colon is saying everything from the split point. Then doing the same for extra features and for the target. You could also create all your test variables here. I didn't create the test variable, but you could do that here. That's further down in my script. Then we're creating the scalars. So one thing you have to do with a lot of machine learning algorithms, and with Bayesian in particular, it's very sensitive to the scale of the values. So if you had spent like if you had a one channel that spent hundreds of thousands, and then you had like an organic variable that that had I don't know, like 10 times as many zeros on the number. Like maybe it was like you had like a million visits from organic. Then the model would get confused between those two. So that's why we need to scale. So they're all kind of within the same range and a small range. And then it still doesn't change the underlying pattern of the data, but it just moves the data down into a smaller range, if that makes sense. Okay, so media scalar, this is from the pre-processing unit. It's kind of using the mean, and then we have extra features, target scalar, cost scalar, and then we're actually using them to scale the data. So we have the media data train, extra features train, target train. So we're doing fit transform to scale the data. Cool. So now we're training the model. And in this case, we're using the carryover model. We actually have 3 different options. So we have carryover, which is basically giving more weight to the near values than the distant ones. So this is kind of like an add stock. We have just a classic add stock, but this one has an infinite lag that decreases as time weighs. So that's like, I think this is more like the standard one. Carryover is what they recommend. And then Hill add stock brings in diminishing returns, which we're not really covering here, but that's if you're spending a lot on the channel, you'll start to see that it gets saturated, and like spending more is going to really hurt performance. For this client, the simulated client, we're not spending a lot per day, or per week, so it shouldn't be a concern. But if you're spending a lot, particularly on some, a lot on, say, like one channel like Facebook, then it might be worth using that hill ad stock. Cool. So don't worry too much about all this. All you're basically doing is just passing in all the data, and then this is essentially like how many Markov chains you use. I don't pretend to know the maths, but it's doing a lot of wizardry to basically try and find the right combination of parameters for the model, and the ones that are most likely to represent the real life kind of values that those channels are driving. So if you think about it, like say Facebook ads is driving a $4 ROI, what it's going to do is it's going to try lots of different numbers and eventually settle upon $4 because it'll kind of realize that like that's the most likely value of Facebook ads. So that's a simplistic example, but it's much more complicated than that. Cool. So when the model is run, and this does take a long time in some cases. Like here, it's only like 4 minutes. That's not too bad. I've got a pretty fast computer, but like if you had a bigger model, you had more data, it can take a longer time. And then once you run the model, then you can do this print summary. So if we just run that, then what this does is it basically shows you the values for each variable in the model. So there's a bunch of different things here. So beta, that's the coefficient. If you know marketing mix modeling, that's what you normally get out. We also have the beta for seasonality because it automatically works that out, and trend. And then, this is the beta for media, for one geo, for the second geo, if that makes sense. So this is like, and then we have the channel beta, and we have the ad effect retention rate. And then these are the betas for the extra features. So there's lots of different variables in this model. We have the intercept, the sigma, the error, and then the peak effect delay. That's also, actually a lot of these things. So the retention rate, the peak effect delay, the channel beta, that's and the beta media. That's all related to the carryover model. If you change the model name, you're going to get different variables because that's what it uses to kind of estimate the curves. But the only thing you really need to check here is, you don't really need to know the model coefficients necessarily. You just want to see what are these R hat values, and right now they're all 1, so that's good. And in theory, rule of thumb is they should be below 1.1. So we shouldn't have any issues here. We can pretty much rely on this model. And then what we do here is we plot the posterior distributions. So this is basically, what the impact of each channel is, like what the parameters were. This is, this is basically kind of showing, the shape of each channel. You can run that, you can see that. The part where it gets really interesting, though, and actually, related back to business value, is when you plot the predicted versus actual. So this is always the money slide for me. It's like, can we actually predict what happened based on this model? And in this case, it looks really good. So this is the predicted KPI. So this is predicted sales in green, and then the true KPI in gray. So you can see the lines follow pretty closely. There are no kind of areas where they've messed up. And in this case, the R squared, so this is from 0 to 1 in terms of how accurate the model fits the data is very high, 0.96. And the MAPE, the mean absolute percentage error. So this is what percentage was it wrong on any given week. It was only 6.75%. So this is really good. I think anything below 10% is usually great. That is the data already knew about, right? So it's a good thing that we can predict existing data, but what about fresh data that we haven't seen before? So that's what this sets up. So here is how you get the media data test and extra features test. So I'm transforming these with the media scalars and extra feature scalars, and then we're running a prediction. And then and you can see the shape of the prediction here. You pass that in to this plot out of sample fit, and then that's showing you how it behaved on data it hasn't seen before. And then again, this is broken down by geo, so it's geo 1, geo 0, geo 0, geo 1. And you can see the R squared is lower, but it's still really good, and the MAPE is still really good as well. So if the MAPE and R squared are really bad for outer sample predictions, then that's a sign that your model was misspecified, and it's not going to be very reliable going forward. Cool. So next thing we want to do is kind of show the media effects. So this is basically saying a lot of the effect for the channels is this second or third channel here, and then this is showing kind of the ROI. ROI looks really good for this channel, but the best way to interpret this is really with the response curves. This is basically showing, as you spend more money, what should you expect in terms of revenue. So this is showing basically like this channel is not driving very much revenue. This channel is driving better revenue, but still pretty bad. And then this channel is driving the best revenue. So you can see here, when you spend 20, you get like $10 back. So this is just simulated data. So it'll look different with your data. Hopefully more ROI positive. But this, that's what it's come out with. The response curve is basically like you can see, where do you want to spend on each channel? In this case, it's pretty clear, that channel 2 is driving a lot of the sales. But you can see different variables. Like sometimes channels are low, but they don't work very well. Like at low spend levels, they saturate. Other channels are like pretty poorly performing, but they saturate later. So, rather than figure all this out yourself, you can run a budget optimization. That's the last thing here. And this is basically, where should you spend your budget if you're kind of keeping your budget the same or increasing it or decreasing it. So prices is just what's used if you inputted like impressions or clicks from your channel. This is like how much does an impression cost or how much does a click cost. If you use media spend like I always use, then you just need an array of ones. That's the length of the channels. So that's what that's doing here. And then we're going to forecast forward for like 10 periods, like how much should we spend? And then we're going to set the budget based on the sum of the media data. So basically, like how much should we previously spend per week multiplied by the number of time periods. And then this here, like we, in order to predict, we need to pass in the extra features. And so what we're doing here is just saying, for the 10 time periods, let's just scale the extra features test and like cut it down to 10 time periods and pass them in as well. So this is just kind of the average of that. Cool. So you pass in the solution. So you pass in the optimized media and it passes out the solution. So you pass in the scalars here as well. And when it comes out, you have this solution.x. That's the actual kind of array. It tells you, what to spend on each channel. And what we're doing here is summing it up times the prices. So that's like for us that doesn't do anything because our prices are 111. But if you were using impressions, that converts it back to spend, and then you compare that with your budget. And what I've done here is just written some code to iterate through them and then show me what the percentage of spend should be. So in this case, it's saying we should spend 25% on Facebook, which is the first channel, 26% on TikTok, and then 50% on Google, because at some point Google starts to saturate potentially here. Cool. So that's a lot to take in. It's pretty complex under the hood. I've based this off the examples in the library. as well as just some kind of looking at the documentation. If you don't know how to code, this is going to be complicated. The main thing you would need to change is not any of the code down here necessarily, but you would need to pull in your data at the top. And that's something potentially I'll cover in another course. But just so you know how to run the tool, how it works, what do these different things mean, now you understand it, hopefully you could figure it out yourself, or at least understand it enough to pass it on to a freelancer and talk to them about what decisions you want to make with these types of models. Cool. Hope you enjoy this and find good use out of it.